Friends, welcome once again, and today we are going to discuss the chapter of curve tracing. Before curve tracing, we will discuss what is an asymptote and how to find the asymptote. So as I told you previous times also, that if you have any problem you can ask me by writing in the comment box, and if you like the channel then please share it and subscribe to it. So let us discuss asymptote first. What is an asymptote and how can we find the asymptote? So asymptote is a branch of the curve, is a straight line to which the curve is not touching, or it is going to meet this at infinity. Suppose the curve is having shape like this. You are all familiar with this curve. This is negative of the exponential, so it is going to meet this x-axis at infinity. So as you know, as x tends towards infinity, y equal to e to the power minus x, so e to the power minus infinity equal to 0, not equal to 0, tending towards 0, as x tends towards infinity, y tending towards 0. So this is called the asymptote. Similarly, we can have the graph of y equal to log x to the base e. This is the graph, so it is going to meet here or touch here at infinity. So actually it is not going to touch, so this is called asymptote. So you can study various types of curves which we will be doing right now. So the curve like this, it is also having these two lines which are asymptote to this at this point. So this branch of the curve is not going to touch this. Similarly here it is not going to touch this. So these lines are called asymptote, and we define them as the straight line to which the curve is going to meet at infinity. Though asymptotes can be parallel to each other, there may be more than one asymptotes. So the number of asymptotes of a curve which it is having depends upon the degree of the equation. If we have a polynomial phi of n degree, phi n x equal to 0, n is the degree of the polynomial. In that case we say that maximum number of asymptotes of such a curve is equal to n, number of n, and is equal to the degree of the curve or the polynomial, and it cannot be more than n. So it does not mean that it is going to have exactly the n number of asymptote. Maximum number of asymptote possible is n. Sometimes the axis may also be the asymptote, x-axis, y-axis. The curves may be having parallel asymptotes, or the asymptotes may be parallel to x and y-axis. So all this we have to find. Now there is a standard procedure for that, and that procedure is, for finding the asymptote, we put the suppose y is equal to mx plus c is an asymptote. This is the equation of a straight line. M is its slope. So you put y is equal to m and x equal to 1 in the equation of the polynomial phi and mx equal to 0, and from this we will be getting the values of m. So the value of m is given by phi n m equal to 0. So this will give you the value of m, and for this we will calculate the value of c. And where do we put these values? Suppose we have a polynomial of third degree, y cube minus x square y plus 2y square plus 4y plus x equal to 0. So what can be the maximum number of asymptotes this curve is having? This is an equation of third degree. Maximum power is 3 here. So it is having 3 asymptotes at the maximum. So how we will find this? We will put y is equal to m and x equal to 1 in highest degree terms. Highest degree terms, this polynomial is third degree, so highest degree terms is 1 is this. So here you will put y is equal to m. This is also third degree, 2 plus 1, so x equal to 1, y equal to m. Other terms are having degree less than 3. So you have to put this in the terms which are having highest degree in the polynomial, and then solve this. Then you will find the value of m. After this, you can find the value of c by using this equation. C is equal to minus of phi n minus m by phi of n dash m. Phi n, this is phi n m equal to 0. So this is phi. So here you will put y is equal to m. So phi m here will be equal to phi 3m here is equal to, because this is a third degree equation, m cube minus 1 into m. Other terms are less than 3 degree, so they will be left. So what is phi 3 dash? Derivative of this with respect to m, 3m square minus 1. You will put this here, phi n minus 1 here. This is a term which is less than 1 degree to this. So phi n minus 1 m here will be equal to phi 2m. Phi 2m means put the same y equal to m, x equal to 1 in second degree terms of this equation. So here we have second degree is y square, y second degree here, because this is 1 less than this. Here phi 3 n is equal to 3, so this will be phi 2m. So put y equal to m here. So this is 2m square only. Other terms are this value of m, and we'll write the. Now this is the procedure when we don't have the parallel asymptotes. Suppose you get more than one values of m which are same. In that case, the asymptotes will be parallel. So there is also a procedure for finding the parallel asymptotes. Let us see what is that. I am talking about asymptotes which are parallel to each other, not parallel to the axis. So for finding the asymptotes which are parallel to asymptotes, suppose we get two values of m which are same. So in that case, there are two asymptotes which are parallel to each other. So in that case, for finding c, I will write c square divided by second derivative of phi n m plus c by factorial 1 multiplied by phi dash n minus 1 m plus phi n minus 2 m is equal to 0. This is the case when we have two asymptotes which are parallel to each other. If we have three asymptotes which are parallel to each other, you will be getting three same values of m. So the equation becomes c cube by factorial 3 phi triple dash n m plus c square by factorial 2 phi dash double dash n minus 1 m plus c by factorial 1 phi dash n minus 2 m plus phi n minus 3 m is equal to 0. Then solving any of these equations, and you will find the asymptotes. So friends, this is the procedure for finding the asymptotes. Now after this, we have asymptotes which are parallel to the axis. How to find the asymptotes parallel to the axis? One thing I should make clear here, that we are discussing here only asymptotes for the Cartesian curves. We have the curves which are known as polar curves, which are for which the coordinates x and y are changed as r and theta, polar coordinates. So I am not talking about them, that we will be discussing separately. Here only for the Cartesian curves. So if you have to find asymptote parallel to axis, how to find the asymptote parallel to axis? If the asymptotes you have to find parallel to y-axis, then you have to equate to 0 the coefficient of highest degree term in y. Is equal to 0, and for asymptote parallel to x-axis, coefficient of highest degree term in x equal to 0. If the coefficient is constant, suppose the highest degree term like y cube plus 2x square plus 3x plus 1 equal to 0. This is the equation of the curve. So what is the highest degree term x in y? If I want to find the asymptote parallel to the y-axis, this is parallel to y-axis. The asymptote parallel to y-axis. So what is the highest power of y? Y cube, and what is the coefficient of this? 1. So this is constant coefficient. It means there is no asymptote parallel to the y-axis. In case if it would have been like this, then highest power of y is having coefficient x equal to 0. That means y-axis is the coefficient parallel to this, y-axis itself is the asymptote. So here parallel to x-axis, highest degree term in x is x square, its coefficient is 2. This is also a constant. It means that this curve is not having asymptote parallel to x or y-axis. Now we will find asymptote to some curves. Suppose the equation given here is x square y square minus a square x square plus y square equal to 0, and we have to find the asymptotes which are parallel to the axis. So you can write this equation in this form. Now what is the highest degree term of x? And before this you should know how many asymptotes this is having maximum. What is the degree of this equation? 2 plus 2, 4. 4 degree equation. So number of asymptotes maximum can be 4. What is the highest power of x? X square. Coefficient of highest power of x is y square minus a square. If I put this equal to 0, y equal to plus minus a. These are the asymptotes which are parallel to the axis. So y equal to plus minus a, this gives you the asymptotes parallel to the x-axis. Similarly, I can write the equation in this form: y square x square minus a square x square equal to 0. The coefficient of highest degree term of y is x square minus a square. Putting this equal to 0, this gives you x equal to plus minus a. So these are the two asymptotes which are parallel to y-axis. Parallel to x, parallel to y, we have in all 4 asymptotes. 2 plus 2, 4. So this is a very simple way to find the asymptotes which are parallel to x or y-axis. This is how you can do. Now next we have a question. The equation of the curve is y cube minus x square y plus 2y square plus 4y plus x equal to 0. We have to find the asymptotes of this. First of all, identify the number of asymptotes. The highest degree term here is y cube. The degree of the equation is 3. So it is having 3 asymptotes, at the maximum, and those we have to find. So putting y equal to m and x equal to 1 in highest degree terms of equation, that is third degree terms. So phi 3m is equal to m cube. This is also third degree term, 2 1 1 minus 1 into m minus m. And if I put this equal to 0, so you get m minus 1, m plus 1 equal to 0. So m equal to 0, 1 and minus 1. So it is having three asymptotes with the slopes of these three asymptotes are given, and you know that c is equal to, because we know y equal to mx plus c is the asymptote. So c is minus phi 2 m by phi 3 dash m. So I can write c is, what is phi 2 m? The second degree terms, we have this only one. So put y equal to m here, 2m square equal to, so now put the value in the equation, minus 2m square over phi 3 dash, the derivative of this with respect to m, 3m square minus 1. So find the value of c for different values of m. For m equal to 0, this is 0, and c for m equal to minus 1 is minus 2 into minus 1 whole square upon 3 minus 2 divided by 3 minus 2, 3 minus 1 2, so this is minus 1. And c for m equal to 1 is minus 2 into 1 divided by 3 into 1 minus 1, minus 2 by 2 minus 1. So the asymptotes are, first is y equal to m is 0 and c1 is 0. So the first asymptote you can find, and then write the equation for the second one and third one. So y is equal to, second is m is minus 1, so minus x, and c for minus 1 is minus 1, and third one is m equal to 1, so x minus 1. So y equal to 0 here is one asymptote. This is the equation of x-axis. So how x-axis is the asymptote? You can simply check. What is the highest degree term of x? It is x square. Coefficient of x square is y. So we will put the highest degree term coefficient in x equal to 0, y equal to 0. So this gives x-axis as the asymptote. This is how you can find the asymptote of the given equation. Now let us move on to the next question. The next question is y equal to, 4x cube minus 3xy square minus y cube plus 2x square minus xy minus y square minus 1 equal to 0. So this is the equation of a polynomial or of a curve. Find the asymptote. If it exists, first of all, the condition is that it should exist. It is not necessary that all the curves are having the asymptotes. So what is the degree of the equation? Degree is maximum power of the variable. So it is 3 here, similarly 3 here, 3 here, and rest are 2 and the constant. So maximum number of asymptotes will be 3, and we have to find those. So phi 3m. Third degree terms are this, put x equal to 1 and y equal to m. So this is 4 minus 3m square minus m cube, and we have phi 2m is equal to, second degree terms are this, this and this. So 2 into 1 minus 1 into m minus m square. So 2 minus m square. And if you put phi 3m equal to 0, so this gives m cube plus 3m square minus 4 is 0. If you put m equal to 1 here, then this is true. That means m equal to 1 is a solution of this equation. So you can solve this. So we can divide this by m minus 1. So if you divide this by m minus 1, you can write this as m minus 1 m plus 2 whole square. So this gives m equal to 1 and minus 2 minus 2. So there are two similar values of m. It means that two asymptotes are parallel to each other. So we have in all three asymptotes. Now we have to find the value of c. So c is equal to minus phi 2m by phi 3 dash m. So this is minus phi 2m is, and phi 3 is this. So its derivative is minus 6m minus 3m square. So c for the first value, which is distinct, m is equal to 1. You put the value here. So this is minus 2 minus 1 divided by minus 6 into 1 minus 3 into 1. So this is 0. So for the first one, we are getting c equal to 0. Now we have to find the value of c for the two asymptotes which are parallel to each other. For that, we will use the equation which I told you about just now. C square by factorial 2 phi, if you check it, just now I told you c square by factorial 2, and this is, there are three asymptotes, so we will be using this equation. Phi 3 double dash m plus c by factorial 1 phi 2 dash m plus phi 1 m equal to 0. And we will solve this equation to find the value of c. So c square by 2, what is phi 3 double dash? Phi 3 dash is this. Its one more derivative is phi 3 double dash. Minus 6 m plus c into phi 2 dash. Phi 2 is this. Its derivative is minus 1 minus 2m plus phi 1. What is phi 1? M. Put y equal to m, x equal to 1 in 1 degree equation. So there is no 1 degree equation, 1 degree term in the equation. So this term will be equal to 0. So phi 1 m is 0, equal to 0. So we can write c square 3c square into 1 plus m plus c 1 plus 2m equal to 0. Now we can put here the two values of m which are equal to each other, minus 2 minus 2. So 3c square 1 plus 2 into minus 2 equal to 0. So minus 3c square plus 1 minus 4, minus 3c is 0. So 3c, c plus 1 is 0. So c equal to 0 and c equal to minus 1. These are two values of c. So you can write the equation for m equal to minus 2. The first asymptote is y is equal to m is minus 2x plus 0, and second is y equal to minus 2x minus 1, and the third one we can write for the value of c. M is 1 and c for m equal to 1 is 0. So third asymptote is y is equal to x plus 0. So this is how you can find the asymptotes in case they are parallel to each other. So this is the very simple method of finding the asymptotes. Now after this we will be discussing how to trace a curve in the next discussion.